Assalamualaikum students. Today's topic is going to be about addition of vector by rectangular component. First of all, let me define a vector. Vector is that quantity which has magnitude as well as direction. Now students, the basic rule of addition of vector is by definition head to tail rule, in which the head of one vector where ends, the tail of the second vector will start from that point. And by doing this we'll get a resultant vector, which is the last vector from the head of the last vector to the tail of the first vector. Sometimes sketch and scale diagrams of complex situation become difficult. That means a diagram cannot reveal the accurate answer. That's why we have to make another method of doing this calculation. Otherwise our answer will be approximate. Another method of addition of vector is called analytical method. This method is more mathematical in nature rather than geometrical. By head to tail rule, our resultant will always be approximately correct because drawing sketch can never be perfect. The answer obtained by analytical method is always the same, therefore can be regarded as accurate. In this method, initially rectangular components of a given vector are calculated, which are x-axis and y-axis. Then the x component of the resultant can be determined by simply adding the x components of all the given vectors. Similarly, by adding the y component of all the given vectors, the y component of the resultant can be determined. By using Pythagoras theorem, the magnitude of the resultant can be computed. That means by this process, by using Pythagoras theorem, which is hypotenuse square is equal to perpendicular square plus base square, we can determine the horizontal and vertical components, and by that we can calculate any resultant of those vectors. Now, to elaborate, the above mentioned procedure consider two vectors, let's say A and B, having angles θ1 and θ2. Let's say that this is our y-axis, which is vertical, and this is our x-axis, which is horizontal. Respectively, with the x direction as shown in figure, we have shown in a form of figure. Let their resultant, which is primarily obtained by adding them according to head to tail rule as shown in figure. Now let us consider vector A in this rectangular component, and this is vector B. Now first of all, let us check the angle between these two vectors, which is along x-axis. So this is θ1, which is along x-axis, which is of vector A, and this is θ2, which is along the x-axis, which is of theta of the vector B. Now let us take the resultant. As I told you, the resultant will be where the second or the last vector ends. The head of the resultant vector will start, arrow will start from there till the first point from which the tail of the first vector. So this line, the purple line which is represented by R, is the resultant or combined effect of these two vectors, which is A and B. Let B the resultant, which is primarily obtained by adding them according to head to tail rule as shown in figure. To find the magnitude of R, the rectangular components method, we resolve vector A and B into their rectangular component as shown in figure. Now instead of head to tail rule, which is quite approximate, we are using analytical method, by which we mean we will not use head to tail rule. We will basically divide these vectors into their components. One is horizontal, we will call it AX. This is the horizontal component of vector A, and one will be AY, which is a vertical component of vector A, represented by a blue line, which is horizontal, and red line, which is vertical. Similarly, in the case of B vector, the blue line is representing the horizontal component of B, whereas the red line is representing the vector or vertical component of vector B. Now, extending these two vectors, because they both are the same vectors, because they have the same direction and almost the same magnitude, and similarly in the case of Bx, same direction and same magnitude, we extended these vectors so that they form a same line along the x-axis and same line along the y-axis. Ax plus bx, similarly ay plus by. Now, if we want to calculate only the horizontal component, that means ax plus bx, then we will have a resultant of Rx. That means which has a combined effect of A and B. So writing them in an equation form, we have Rx is equal to Ax plus Bx. Now for the vertical component. For that, we will have only the vertical component, which is Ay and By. We have taken it along the y-axis. Combining them both, we have Ry, which is a combined effect of A and B vectors, representing them in the form of vector or equation. Ry is equal to Ay plus By. Now the magnitude of the resultant can be calculated by Pythagoras theorem. We all know that is the vertical line and horizontal line. By Pythagoras theorem, we mean that means there's a perpendicular, there's a base, and there's a hypotenuse. Now students, we are using the hypotenuse. That means hypotenuse square is equal to base square plus perpendicular square, or in other words, the modulus of r is equal to under root r square rx square plus ry square. The horizontal and vertical components are being added up by Pythagoras theorem now. Let us call this equation number 1. Let theta be the angle which is the resultant makes with the x direction in anti-clockwise sense. Its direction can be determined as this is the theta angle which is along the x-axis and it is moving in the anti-clockwise direction. It can be determined by tan. Tan is equal to perpendicular over hypotenuse, where the perpendicular part is ry and the base part is rx. To find the value of theta, we take the tan to the other side, it will be tan inverse ry over rx, where ry is the perpendicular and rx is the base. Let us call this equation 2. These were for only two vectors. What if we have more than two vectors? The above equation can be used to find the result of any number of coplanar vectors. That means we can use multiple number of vectors now. Thus, by adding the x component of all the given vectors, we get the x component of the resultant vector as all the given vectors along the x-axis will be given as ax plus bx plus cx plus dx and so on. Similarly, we have the vertical component. Similarly, by adding the y component of all the given vectors, we get the y component of all the resultant as ry is equal to ay plus by plus cy plus dy and so on. Let us call this equation number 4. Now by using equation 1 and 2, which are the magnitude and the direction, the magnitude and direction of a resultant can be determined. Any vector can be determined rather than by using head to tail rule. We can use addition of vector by its rectangular components. Let us revise the rectangular component in the form of a summary. Steps of vector addition by rectangular components method. First step of vector addition by rectangular component methods are draw individual vectors being used, summed, and the axis being used. Find the x and y components of all the given vectors. Find the x component of Rx of the resultant by the adding x component of all the given vectors. Find the y component Ry of the resultant by adding the y component of all the given vectors. Find the magnitude of the resultant vector I by using Pythagoras theorem. R modulus is equal to under root Rx square plus Ry square. Find the direction of the resultant vector by using tan formula. Tan is equal to Ry over Rx, that is mean perpendicular over base, and by that we can find the value of theta, which is equal to tan inverse Ry over Rx. Now let us revise in the form of animation that we will choose two axes, one y-axis and one x-axis. We have two vectors over here, a and b, which have a theta 1, theta 2. We divide them rather than using head to tail rule. We are basically now dividing them by their components, which is horizontal and vertical, and so along the B, the horizontal and the vertical component, extending the vertical components so that we have a full range of all the vectors which is along the x-axis and full vectors along the y-axis. Now we'll take all the vectors, add them up, we will get a vector which is Rx. Similarly, we will add all the vector and we'll get Ry. And by head to tail rule or using Pythagoras theorem, we can determine the value of R, the magnitude part by Pythagoras theorem and the direction part by using the formula of tan. Now students, here the theta is the angle which result vector makes with positive x-axis in anti-clockwise sense. The sign Rx and Ry determine the quadrant in which theta lies. That means there are four quadrants: first, second, third, and fourth. To determine the theta, following procedure must be adopted. Respective of the sign Rx and Ry, find the value of tan inverse Ry over Rx by using a calculator called this angle phi. That means in which quadrant we are taking the vector, which is the component vector. Like in this case, we have two components, which in the first quadrant, the x-axis is positive, y-axis is also positive, so the resultant will be in the first quadrant. If Rx and Ry both are positive, then the angle theta, the direction of the resultant is same as of phi as shown in the figure. That means the phi is also in this direction in the first quadrant. Similarly, in the second quadrant, if Rx is negative, that means there is a negative x-axis is there, and Ry is positive, that means y component is still positive because it is above the 0 point, lies in the second quadrant and can be determined as theta is equal to 180 minus phi. Why it is called 180? Because the line over here starts from 0 and goes to 90 and then 180. It will be equal to 180 minus tan inverse Ry over Rx. That means it is in the second quadrant. Similarly, in the third quadrant, as you can see, both the vectors, the x components and the y components, both are in negative direction. So we can write down as if Rx and Ry both are negative, then theta lies in the third quadrant and can be determined as theta is equal to 180 plus phi or 180 plus tan inverse Ry over Rx. Last quadrant, if Rx is positive, that means Rx is positive, which is positive x-axis, and Ry is negative, which is negative y-axis, theta lies in the fourth quadrant and can be determined by as theta is equal to 360 minus phi, or it can be represented as 360 minus tan inverse Ry over Rx. So last, we can see all of these quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. Student, what we have learned today, we have learned addition of vector by rectangular components. Thank you very much. Inshallah, we'll meet again.